Hi. The objective of the next generation of wind turbine are quite simple. We need first to reduce the noise. Second, we need to reduce the visual impact, the visual disturbance. And third, we need to cut the production cost of electricity by about 1/2, because we need to be competitive with charcoal and gas, coal, without subsidies. The Windu solution turned around a 10 kilowatt wind turbine that's going to be modular and that's going to work in network. It's going to work in network in a way so we're going to be able to produce large quantity of electricity, megawatt if we need. And modular because the way it's going to be assembled, it's going to be easy to use small part that can be produced in high quantity, and it's going to be adaptable to it. So a wind turbine, a 10 kilowatt wind turbine, start with a foundation that's going to be one pillar. We're going to hammer that pillar on the ground, and it's about 30 feet pillar, and this is the same steel tube that is used to hold a building or bridge. And a team of 3 persons with appropriate equipment going to install 5 to 10 pillar per day, or 5 to 10 foundation for wind turbine. So relatively cheap. The second part is a standard column of 10 meter that's gonna grab the generator of 10 kilowatt. So it's standard part, standard steel part available everywhere, and the 10 kilowatt generator is an apparatus about this size that thousands of factories can do. The assembly of the modular turbine is also something that's going to be can be done with automation. It's the plate going to be die-cast plastic, and the pail going to be aluminum extrusion. So it's all process that is available everywhere, and it could turn to be very cheap if it's done in good quantity. We see in the previous presentation that the modular system of Windu is about 10 stair high. It's in general it's going to be 10 stair high, and it's done a different model that's going to be adaptable to the wind speed. The vertical axis wind turbine have all different efficiency curve depending on the configuration. Configuration means the shape of the pail. There's 1,000 kind of pail it can be used. The size of the pail, the angle of attack, the wind speed, the number of pail. It's all make wind turbine different one to the other. So some are very good with low wind, and the efficiency rapidly damper with a higher speed wind, and some are very efficient with high wind, but not very efficient with low speed wind. If we make a mix of several configurations, we're going to be able to produce a wind turbine, a modular wind turbine that may be going to have a smaller peak of efficiency, but going to have a wider spread of use, of efficient use. So it's going to be more flexible for depending on the site where we're going to be. The configuration you just see is appropriate to a standard wind farm site. You have some site where every site got what I call an histogram that describe the general, how much wind you got of every speed in a year, and that gives you an average where you can start to establish the optimum wind turbine according to the site. So if you have, like this one, a very high section of high speed, you need specific configuration. On the other side, if you have a site with a lot of low speed period, you need a machine that is more efficient in low speed. A modular wind turbine is not only mixing a 10 stair turbine that that you mix the stair to adapt to the wind speed, the average wind speed of a site. You can go further. You can, when you have a very low wind site, you can add more stair. You can say, okay, we're going to make 12 or we're going to make 15 stair in order to harness a larger quantity of wind. And on the reverse, if you have a site that is extremely windy, you can reduce the number of stair, maybe as low as 5 stair, because it's enough to supply 10 kilowatt. And the principle is to keep everywhere the same foundation, the same column, the same generator. Everything is the same, so it's mass production in big quantity, but we adapt the turbine to the site. And where there's low wind, in general, the maximum wind speed you can have in the last 50 years of history is much lower than the site with high speed wind. And you need to calculate, you need to be sure when you make this kind of stuff that if you eventually reach that maximum speed, the machine is going to stay there. And when you have a low wind site, in general, the maximum speed is much lower, so the system, the structure can support 15 steps. And on the other side, when you have a site with a lot of wind, it's generally a coastal site. You can have important peak, and your machine need to be stronger, need to be able to support much stronger wind at certain time of the year, and it's a good idea to reduce. But you're going to produce the same amount of electricity. In fact, a 15 stair wind turbine on a low wind site going to cost a little more to install per machine, per apparatus, and even there it's going to produce less electricity, because when the wind is low, the energy is much less. So those installations won't be able to be competitive with gas and coal electricity production. But as we're going to see on the market video, there is other situation where it could be very interesting. On the other hand, if we have a very windy site with 5 stair wind turbine, the turbine is cheaper because everything is the same. We have a smaller head on it, and we're going to produce much more electricity, because high-speed wind contain a huge amount of energy. And there we're going to produce electricity below 2 cents per kilowatt hour, cheaper than any fossil energy. The design of those, of all those stairs, there won't be many, maybe 4 or 5 different configurations. The design of those stairs is going to be optimized by a computer fluid dynamic. It's a computer engineering system that is not a simulation, that is not a drawing of what we think is going to happen, but it's an engineering process that gives us a very tight information on the productivity of what we're going to do, what we're going to build. And this is important, and we're gonna make a small presentation in another video to make sure everybody understands what is CFD. So I hope all this small presentation gives you a better idea of what is a modular wind turbine and what is a network wind turbine. If you have any question, of course, you feel free to post it on our blog. So thank you.